Hey, it's Mr. Allred, and we're going to talk about the distributive property. So, with the distributive property, you may recognize it. It usually involves some parentheses, but it's where we have something outside of parentheses and we're trying to multiply it through the parentheses. So, here I have A times the quantity of B plus C. And the way we handle that, usually we think of as distributing that A to the B and then to the C, or whatever terms are there. And over here on the right hand side of that, we see the A has been multiplied. It was multiplied to the group before. Now it's multiplied to the B and the C individually. So that becomes AB plus AC. So that's the distributive property in a nutshell, but we don't always just do it with numbers or single variables. It's a good chance we might end up doing it with expressions. So here's some examples below. So the first one here, we have 6x, and it's times the quantity of 2x plus 5. And if you're used to doing this, the 6x here is the A up above, and the 2x is the B, and the 5 is the C. But we're just going to take that 6x and we're going to multiply it by every term inside. So when we do that, we see 6x times 2x, which will give us 12x squared. So multiplying the numbers and combining the exponents on the variables. And then plus 30x for the 6x times 5. Okay. So we distributed the 6x and we got rid of those parentheses. The second example here is 5y times the quantity of 3y plus 5y squared. So we're going to hit each one of those. So 7y times 3y would be 21y squared. And then 7y times 5y squared will be 35y cubed. So make sure you're understanding how exponents combine when you have variables. Okay. So here's some more lengthy problems with the distributive property. I may not have left myself a lot of room here, but let's see. So one way I like to look at things when I have polynomials multiplied together or more than a single expression, and in this one I have 3x plus 4y times the quantity of 2x plus 5. I'm going to take the 3x and multiply it by the other side, and I'm going to take the 4y and multiply it by the other expression. So let me write that out the way I would do it. You may have a different way and that'll be fine, but it'll be 3x times the 2x plus 5. And then we'll take and we'll add to it the 4y times the 2x plus 5. Okay. Then we can actually do our distributive property on each one. So the 3x will go into the 2x and the 5. The 4y will go into the 2x and the 5. So what we'll get here is 6x squared plus 15x plus 8xy plus 20y. And let's draw a big line here to separate these. So that's the top problem here. Okay, so we pushed a long expression into another long expression. And this is pretty useful because now we can talk about the second one down below here. We've got the big expression 3x squared plus 2x plus 4, and that's going to be multiplied by 5x minus 4x squared. So we're going to take these things, the 3x squared, and distribute it to the other expression, the 2x, distribute it to the other expression, and the 4. So this is going to help you maintain what's being multiplied together. So let's see. Let's come down here, and hopefully we'll have enough room to put everything. But we'll have 3x squared times the 5x minus 4x squared, and it'll be plus 2x times the 5x minus 4x squared, and the 4 from the first expression times the 5x minus 4x squared. Okay, which will give us a lot of stuff. Let's write it out. So in the first one, we'll have 15x cubed minus 12x to the fourth plus 10x squared minus 8x cubed plus 20x minus 16x squared. And that's a lot of terms. That's 6. And the reason we got 6 terms right now is because we had 3 things minus 2 things. Excuse me, 3 things times 2 things. So that gave us 6 things. But let's see. There's some like terms down here, I believe. Let's see what we can collect over here for a final answer. So there's only one term that has an x to the fourth, and that's minus 12x to the fourth. But let's see. There are 2 terms with an x cubed. So that's 15x cubed minus 8x cubed. So that gives us 7x cubed. Let's see where that comes from. We have 2 things with an x squared. We have 10x squared minus 16x squared. So that will give me minus 6x squared. And the last thing that's left is just 20x, so there's nothing to combine that with, so plus 20x. Okay, so there we have the solution to that second part. And I'm not sure how I can separate these two clearer. Okay, let's try and go back and say example 1, and down here we'll say example 2. Maybe that'll help later on. Alright, so I want to do one more thing with the distributive property, something that most people probably are aware of, and that is the FOIL method. So a lot of people know the mnemonic FOIL stands for first, outer, inner, last, F-O-I-L. But this is a way of kind of circumventing the distributive property if you have 2 binomials. So that means 2 things times 2 other things. So here's how I'm going to draw this out. I've got 2x plus 5 times the quantity of 4x minus 7. So we're going to take the first in each one, okay, which is 2x times 4x, which will be 8x squared. Then we're going to take the outer, which will be, let me replace that a little bit better. I don't think it went to the best place. We'll put it here so it looks better. Bear with me. That's not erasing. Okay, I apologize. So the first was the 2x times the 4x, which gave us 8x squared. The outer would be 2x and the negative 7, which will give us negative 14x. The inner will be the 5 and the 4x, which will give me 20x, and the last will be the 5 and the negative 7. Okay, so that will be negative 35. And in here there are some like terms, the negative 14x and the positive 20x. So when I combine those in the end, I will have 8x squared plus 6x minus 35. Okay. So I did this a little bit different than I did with the distributive property in the previous examples. This is a little mnemonic where people don't necessarily have to do that middle step and say 2x times 4x minus 7 and 5 times 4x minus 7, but you'll get to the same place. One more example with that, if you like. We've got 3x squared minus 4, and all that is times 4x plus 9. So our first is 3x squared times 4x, and that'll give me 12x cubed. My outer is 3x squared plus 9, so that should give me 27x squared, I believe. My inner, it's a mess here, negative 4 times 4x. That gives me negative 16x. And my last is negative 4 times 9, so that's minus 36. And in this one, there were no like terms to combine. But the mnemonic first, outer, inner, last for a 2 by 2 just kind of helps you make sure you capture every single product that should come out of that distributed property without having to rewrite it in an expanded form. But that only works for a 2x2. So if you have one thing times many, it's fine. You just push it all the way through. Two things times two things, you got FOIL. If you have any other situation, then you really need to start looking at it as a distributed property like we did on the previous slide and multiply every term from the first times every term from the second. And distributed property will help you keep up with that instead of randomly guessing or doing some of them and not knowing which ones you missed or if you missed some. All right, let's move on here. There we go.